I guess, would it, maybe let me screen share. I had a brief presentation. Is that helpful?
Yes.
And let me ask, this should be visible to you now. So, sustainable transit-oriented development. What I'm going to do is really just try to hit on 3 ideas. And all I have time is to do is to tell you the idea. I won't have time to explain the research methods underlying that, or the data, or how we came to those results. So because I'm combining, in effect, 3 different findings from 3 different literatures. So so if you want more, if there isn't enough link in the slide deck to direct you to where you could get more information, reach out to me via Farah or Ova, and I could get you more. I think there's 3 things I want to talk about. First of all, the throughput characteristics, literally how many people you can move. And these are fairly standard engineering numbers. The references are down at the bottom and with the formatting a little messed up, also up near the top. And the short answer is that a lane of freeway can move at its peak capacity around 2,000 to 2,000 cars per hour. Around 2,000 to 2,200 cars per hour. So depending on how many people are in that car, you could have as few as 2,000 to 2,200 persons. And in many countries, you don't get a lot more. So let's make this simple and say a freeway lane can move about 2,000 persons per hour. At the high end of the throughput capacity, heavy rail can move 40,000 to 50,000 persons per hour. And so in a lot of cities, we're running out of land. We literally don't have enough land to build an auto-only transportation system that can accommodate the throughput that we need. And remember, if you were to, these numbers are per direction per hour. If you had an option between taking a subway system running at 2-minute frequencies, which is possible per best practices internationally, you could hit that 50,000 persons per direction per hour. If you wanted to move the same number of people in single occupant automobiles, you'd need 25 lanes of freeway going in one direction, or 50 lanes going in both directions. And I don't know of any urban areas in the world that have space for 50 lanes of freeway. So the first issue is really high capacity throughput. And you need a whole system, but heavy rail transit becomes essential as part of that. The second question is, if you have a rail transit system, how do you get people back and forth to that system? And what I'm showing you, this slide will take a little bit of description, but what I'm showing you is the result of an analysis that we did in San Diego in California. And the numbers, our analysis started in a lower income community relatively close to downtown San Diego. And we routed trips over the car network, the road network, and the transit network at 9 a.m. in the morning peak hour. And we asked, in a 30-minute trip by car or by transit, how many jobs and these were classified as jobs that would be accessible to a low-wage person. How many jobs could a low-wage worker reach? By car, at the morning peak hour, the answer is circled in red. From this neighborhood, in a 30-minute car trip, a worker could reach 444,000 jobs. By transit, if they walk to and from the station, they could reach 24,000 jobs in 30 minutes. So the first thing that jumps out is the dramatic difference between car and transit accessibility, and this is due to the low density urban form in the United States. But the next thing we did is what I really wanted to focus on. In blue, we ran some simulations asking, how could we change that transit job access number, again, with a 30-minute travel time, if we moved your first last mile access to a transit station to bicycle speed, and the number goes up to 46,000. Or if we moved it to car speed, the number goes up to 56,000. And then we said, well, what if we didn't worry about first last mile access? What if we tried to reduce the headways, increase the bus frequency? So what you're seeing is two simulated transit frequency headway reductions in green, one by 25% and one by 50%. We simulated this for the entire transit system in San Diego County, a county with 3 million persons. So that 50% headway reduction means every transit line in the entire system, we said, cut that headway in half, which probably means doubling the bus fleet, doubling the number of bus drivers. It's massively expensive. And even if you do that, you don't get to a job access number that you could get if you did something much simpler, meaning just move people back and forth to the transit station by bicycle rather than walking. So what we're showing here is the way in which, if you could take that first last mile trip and move it from walk speed to what we calculated as bicycle speed, you get an accessibility increase that is larger than anything we could do with frequency increases. And this result has held up in other urban areas in the US. So the second result is really the importance of first last mile access and the way in which that's a really important tool for the health of the transit system. And then the third thing, building housing near transit. Let me explain this bar chart. It's going to take a little bit of explanation. By the way, I've got this is an open source article here that if you were able to copy that link, you could reach that article. It's totally open source. What we're doing is we are simulating how taking a representative household and moving them 1 mile further from a rail transit station in greater Los Angeles will increase their driving. Now, this is based on a regression analysis of how driving relates to both income and to location near transit. And so this is all regression controlled. And if you move that household from 0 miles right next to the transit station to 1 mile out, if they are a relatively low income household earning less than $25,000 a year, they'll drive 5 miles more. If they're a high income household, $100,000 a year or more, they'll drive 7 miles more. So the first thing to notice, run this story in reverse. If we could take a household from 1 mile away from transit and put them right next to the station, we could cut their driving by 7 miles per household per day. These are miles per household per day. For a high-income household, 5 miles per household per day for a low-income household. The daily averages for a high-income household are about 60 miles per household per day. So this would be about a 10% driving reduction. For a low-income household, it's about 20 miles per household per day. So that 5 mile reduction would be about a 25% reduction. And we keep doing this for what would happen if you moved a household from 1 to 2 miles, 2 to 3 miles, 3 to 4 miles, 4 to 5 miles. So you could think about this in reverse. If we could pull a household from 5 miles out away from rail to 4 miles out, we're still getting statistically significant driving reductions on the order of 1.5 miles per household per day at the high income, about 3/4 of a mile per household per day at the low income. So a few things to notice. These driving reductions are meaningfully big. They run from 10% to 25% of household driving reduction in the range within 1 mile from transit. So that's thing number one. If you could get, the more you can have housing right next to transit, the better off you are. And in the US context, the less driving you will have. The second thing to notice, this effect is stretching out pretty far. We picked it up as far as 5 miles from the rail station. Now there's probably a lot going on there. This is probably not people accessing rail. This is probably associated with development patterns in rail areas that extend further out that lead to shorter driving trips. The last thing to notice, every step of the way, we get more driving reduction by putting rich households near transit than we get by putting poor households near transit. That's because rich households in the US drive considerably more, 3 to 4 times as much as low-income households. So if you drive more, you have more ability to reduce your driving. We argue that you'd want to have affordable housing near transit for persons of low income, but it's an equity motivation that, we should be cautious. There's driving reduction everywhere, but you actually want some housing opportunities that cater to the high income because their driving reduction may be larger. I think I've run through everything. So I just had a couple of pictures in here to point out that there was a time not long ago, in the 1960s or even more recently, when our transportation systems were contributing to pollution, traffic congestion, and people thought that somehow we had spoiled our cities and lost a chance for an urban paradise. And so what I'd argue is maybe we can get to a paradise found by rebuilding different kinds of systems. And so I think that is everything that I've got. Let me pause and hand the floor back to you, Farah.